started on two-pointer technique. So I have listed a couple of problems. So you will also find practice problems. So better you practice all these problems. So let's see. Uh, so this is our problem statement. So what is trying to say, you will be given a sorted array. So if you closely see here, you will be given a sorted array like 2, 7, 11, 15 and the target. So there is a target with the value 9. So we need to find out two indexes where sum of those two index values is equal to 9. So in this case, if you closely see, sum of 2 and 7 which is equal to 9. So 2 is at 0th index, 0, 1, 2, 3, right? So 2 is at 0th index, 7 is at first index. But the expectation is thinking that index number starting from 1. So ideally, with respect to array, index number is starting from 0, right? So obviously, while returning the output, so we'll just add +1. So the expected output is 1 comma 2. So we just need to return the index numbers. But as per the problem statement, the index numbers are starting from 1. So that's why if it is 0, it becomes 1. If it is 1, it becomes 2. Uh, so how do you do it? One key point is the array is sorted. So the array is sorted. We need to find out two values where sum of those two values is equal to target and return the index numbers. As the index number starting from 1 with respect to problem statement, we'll add +1 and return. That's it. So problem statement is clear, right? Correct? Problem statement is clear, right? Yeah. Can you tell me the brute force approach before we move on to the optimistic solution? So can you tell me brute force approach? So this is our input, right? So we have 2, 7, 11, 15. So 2, 7, 11, 15. So the array is sorted. So that's what a problem statement is saying. Array is sorted. So we need to find out two indexes where sum is equal to 9. Right. So how do you do with brute force? Any idea, please? Yes. So that's a straightforward, right? So first we start from index 0. So at index 0 we have value 2. Then we compare with next indexes. So we have index 1. Yeah, so we compare with the next index values. So from index 0 after you get what? Index 1, index 2, 3, 4, right? So this is 1, 2, 3. So at index 1 we have 7. So 2 plus 7, so which is 9. So we already got the answers. We'll just return this is at index 1. So we simply return those indexes 0 and 1. But ideally the expected answer is 0. With respect to our code, the answer is 0, 1. But is the problem statement saying that index is starting from 1. So we'll just return 1 and 2. What if the problem, let me take something tricky one. So let's say I have 2, 1, -3 and -1 +3. So let's go blindly. Let's go blindly without focusing on it. So first I'll start. This is 0, 1, 2, 3, 4. So first I start from index 0. Then I compare with the remaining indexes 1, 2, 3, 4, right? So at 1 you have 1, -3, -1 and 3. So I'll just add. If I add at 0 index we have 2. So 2 plus 1 which is 3. 2 minus 3 which is -1. So 2 minus 1 which is +1 and 2 plus 3 so which is going to be 5. Similarly, I'll start with index 1. Uh, at index 1 we have value 2 so which is moving on to index 2, 3, 4. So at index 2 we have -3, -1 and 3. So 2 minus 3 it is -1 which is +1 and which is 5 and so on. So just in this way you will just do it. For example, if the target is, assume you have target as 0. If you have target as 0, so what is when do you get the 0? Minus 1, which is at index 1 you have minus 1, right? So at index 1 we have plus 1. So it is minus 2, 0, plus 4. Yeah. So obviously, if you see if the target is 0, so these two indexes returns target 0. There can be multiple answers from a given input. The expected result is there can be multiple answers, but you can return any one of the answers. So the sum of index 1 and index 3, which is equal to 0, so obviously you will return it. So I think you understood the brute force side. It is, what is the time complexity here? What is the time complexity here? Yeah, obviously n square. So if you say, if I write the pseudocode, this is how it is, right? So you have for loop, so I is starting from 0 to n minus 1. Then you have for where j is starting from I plus 1 to n minus 1. Then whenever you feel the array of I and array of j, which is equal to target, then you will simply return a new array, new integer array of as the index number starting from 1, so you can return I plus 1 comma j plus 1. So this is a simple code. You can try this out. So here obviously the time complexity is n square. And what is the space complexity? Yeah, obviously constant, because irrespective of the input, we are purely depending on two variables. That's it. So even the input size is million, we are not taking any additional space, so which is going to be constant. Now, can you tell me the optimistic solution? So you have 2, 7, 11, 15. Let's say you don't know anything about hashing and everything, but the target is 9, right? So target is 9. Come up with the optimistic solution. The key point is the problem statement stating that array is sorted. So array is sorted, right? So that's a key point. So let me explain. So you have 2, 7, 11, and 15, right? You, if the array is sorted, right, you pick up any value. So for example, you have 0, 1, 2, 3. So you pick up any value. For example, if I pick up value at index 2, all the values towards right from this index are greater than the 11, and all the values towards left from this index are less than the 11. So you know that when the array is sorted, so you pick up any element, left side you have smaller elements, right side you have greater elements, greater or equal elements. So we need to find out a target. So what we can do, this is where we can apply a concept of two pointer. So let's do that. How can we do it? So assume you have left is here, right is here. So we know that target is 9. Target is 9. So left is here, right is here. So the current sum, if you closely see the current sum, which is going to be left plus right, so 2 plus 15, so which is going to be 17. So as 17 greater than target 9, so what should I do? I need what? Target 9, right? I need target 9, but I got the current target as 17. Then what should I do? Yeah, so before move the right pointer, that's a solution we need. But why we need to move right? So, yes, yes. So the point is we need we need 9, but we got 17, right? It means we need a smaller value. So we need a smaller value. To get a smaller value, move the right pointer towards left. so that the sum will become smaller. So that what I will do next step, so I'll just take 2, 7, 11, 15. So the left will remain same. I'll just move right towards left because I need this is the case, right? So my current sum is greater than target, so that I just move right pointer towards left. So once I move it, so this is what I get. Now if you closely see, the sum is going to be 2 plus 11, so which is going to be 13. So obviously again the 13 is greater than 9. So again my current value is greater than target. So I need smallest value. So to get the smallest value, simply what I'll do, again I move right towards left. So you have left and right will come here. So obviously current sum, which is equal to 9, because 2 plus 7, so which is 9, which is equal to target. I got the result, so that I can simply return those index plus 1s. So I can return left plus 1 comma right plus 1. That's it. You get it, right? This is simple problem. I think you everyone get it. Correct? Any questions? Okay, no questions. Good. So now let me take you one more input so that we can cover both the cases. Let's take the previous example as 2, 1 minus 3 plus 1. Yeah. Yeah. So this is our input. So if you closely see, this is our left. One second. Target is 0. So if the target is 0, simply what you can do, better 2 minus 3 plus 1 minus 1. Okay, so let's take some more tricky. So here you have right. Right, obviously this is 2, so you will get sum as 2 minus 1, so which is going to be plus 1. So obviously which is greater, yeah, sorry, yeah. Thank you, man. What happened? What is the input here? Oh, this is wrong input. We went into wrong input. Okay, let me take 2, 7, 9. So we need target 17. Let's say we need target 17. So this is our left and this is our right. So if you closely see, our left plus right will be 2 plus 10. So we will get 12. So which is less than the target. So that what we do, we need higher value, right? Just move right towards left towards right. So in that case, 2, 7, 9, 10. So left is here, right is here. So obviously you get value 17 because 7 plus 10, so value 17, which is equal to target 17. So just return those indexes. That's it. So left is pointing to index 1, right is pointing to index 3. So you just need to return left plus 1 comma right plus 1. So what is the time complexity here? Can you tell me what is the time complexity? Linear, right? So obviously you always you just need single loop and we handle with 2 pointers, which is going to be linear. What is the space complexity? Yeah, so obviously which is constant. So let me, you can try the brute force. I will just submit this code. Simple, so we'll take left is 0 and right is going to be numbers dot length minus 1. Simple, so we'll just move as long as left is less than right, because why we need two values, right? So obviously left should be less than right, and we'll get the current sum nums of left plus nums of right. So whenever your current sum which is equal target, you can simply return new array with left plus 1 right plus 1. Okay. Otherwise, if your sum is greater than target, it means you need a smallest value. To get a smallest value, decrease the right pointer. Otherwise, sum is less than target so that you can increase the left pointer. So in worst case, you may not have the target, but in this case, I think there will be one solution in the input always. Just to suppress the error, just return an empty array. Numbers, it is numbers. Okay. So that's it. So yeah. Let's try next problem. This is really very interesting and it needs little more intelligence. So based on the current problem, right, you can solve all these three problems. So we have discussed 2 sum 2, right? You can solve remaining three problems. Try spending on it. Problem number 283 is a little tricky, and don't see any solution, even if it is taking time, no problem. You put some time and learn the concept behind it. So let's solve sort colors. So what he's trying to say is, you will be given an input array. You will be given an input array and which contains only three values. So the values are 0, 1, 2. That's it. There are only three values present in a given input array. The expected result is we just need to sort it. So see, we'll have only three values, 0, 1, 2, which is representing color red, white, and blue. So we just need to sort it. That's it. So let me take the current input. Which is, yeah. So let's say you have an input 2021110. So we have only three values, 0, 1, 2. We just need to sort it. Can you tell me what is a brute force? Okay, sort the array. So that is sorting technique. Okay, so one simple way is you can use arrays.sort. We didn't learn about how the sorting technique works, but we will go through it in future sessions. But one simple way is you can sort it. Okay, you sort it. So once you sort it, obviously the best sorting technique is going to take n log n. That's a time complexity. Okay, so we can park it aside. And what is other way? How many loops? Okay, you iterate to two loops. So how do you figure out how do you swap it? Let's say you have 201. Hmm. Okay, you swap it. So okay, it becomes 102. Then okay, that will not work. You can try it out. Can you come up with other case? I think simply na. A brute force means you should think like a dummy. So one simplest way is what we can traverse and find out how many number of ones, right? How many number of ones we have in the given input? We'll go in order, right? So we can do one thing, right? So we can find out number of zeros first. Let's go in order. Number of zeros are two, and number of ones also two, and number of twos also two. So it means we maintain three variables, which will just calculate how many ones, how many zeros and twos. Then simply what we do, we take an additional array or same array. So let's take a new array. So number of zeros are zeros, two. So I will keep two zeros. Number of ones are two. So I'll keep two ones. Number of twos are two. So I'll keep two twos. So this is our final output, right? So it all depends on whether you update the same array or new array. If you update the same array, you don't need additional space. So what is the time complexity for this algorithm? What is the time complexity here, please? We need to find out number of zeros, ones, and twos in a given input, right? So how do you find out? Yes, it is linear, right? So simply I want to append this to here. Okay, yeah. So it obviously linear, right? So because you don't need to do any additional work. So simply you will maintain three variables, and whenever 0 comes, you increment the 0 variable, 1 comes, you increment 1, similarly for 2. So you will find out how many zeros, ones, twos you have. So you will just update the same array. If you update the same array, then it is going to be constant space. But if you take a new array, then it is going to be linear. So the time complexity also linear, right? Now, can you come up with different solution? So you understood that this is very tricky problem. So let me explain in a better way. So you have 2 0 2 1 1 0. So let's understand the problem statement says only there are three types of values, either 0 or 1 or 2. There are only three values. So we know that all the zeros should be on left, one should be on middle, all the twos should be on the right. Correct? Right now? So if you see, yeah, the problem statement says it has only zeros, ones, and twos, right? So and we know that all the zeros will be on left, all the will be on the right, and ones will be on the middle. That is how it is, right? So that is how the sorted array contains. For example, if you see here, zeros were on left, twos were on right, and ones will be on the middle, right? So it means I definitely need three pointers because I need to represent three values. So let's say I'm having left and I'm having right. To represent this middle, right, I can call it as current. Okay, so I can call it as current, right? So one thing for sure. So first I'll compare my current. What? Yeah, okay. So I have three variables, right? Left, right, and current. Now tell me what left should point to. What current should point to. So instead of current, this middle one I am representing as current, and this is left, and this is right. Can you tell me what left should point to, what current should point to, and what right should point to? If you see, right should always point to what, left should always point to what. Can you think one more time? One thing is very clear, right? Once you sort it, so you have 0, 0, 1, 1, and 2, 2, right? So on the left part you have zeros, on the right part you have this is right part and this is left part. You can call it as middle. So middle we are representing as current. The middle is pointing to ones. Now when my left pointer is valid, when my right pointer is valid, when my current pointer is valid. No, 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 don't worry about indexes with respect to values. Yeah, correct. What you are saying is correct, Maithili, but better you speak in values. When my left pointer is valid, at what for which value left is valid, for which value right is valid. Okay, let me reveal it. So left is valid only when it is holding 0, right? Left pointer is pointing to 0th value, then it is valid. When right pointer is pointing to second value number 2, which is valid. When current pointer is pointing to value number 1, which is valid. Correct? Yes or no? Everyone is clear or any clarity needed? So the point is we need to figure that out. Left is valid when the current value is 1. Sorry, left is valid when the current value is 0. Right is valid when the current value is 2. And current is always pointing to value 1. Right? So what with this concept, I will just iterate through this. Okay. And this also gives an intuition that when left is pointing to value number 2, then when left is pointing to value number 2, and I know that I need to swap with the right, because right is when left is pointing to value number 2, I need to swap with the right. Why? Because right should have the value of 2. Right is valid when it is pointing to value 2. So now if you closely see, here I am, right? So this is my current. So what you can do, you cannot manipulate with left and right. You can spend some time on it. So I can switch with the current pointer. So this current pointer will hold it. So one thing very sure, whenever my current pointer is pointing to value number 2, I need to swap with the right. So if you see here, you have 2, 0, 2, 1, 1, 0, and this is my current, this is my left, and this is my right. So if you closely see, my current is pointing to value number 2, and I know that where this should present. So it should blindly move to the right pointer, because right 2 should always be on the right place. So what I do, whenever it is pointing to this, so what I can do, I can simply swap it. So what I am trying to do, so I'm just taking this current and swapping with this right. So once I swap it, so what will happen? 0 will come here, 0 will come here. There is no change on these values, 0, 2, 1, 1. And this 2 will go here, so 2 will go here. Now, this is where, which is more important. This is my current and this is my left. And you don't know which value you swapped from the right? It can be 0 or it can be 1 or it can be 2 also. You don't know which value you swapped from the right. From the current, when the current is pointing to value 2, you swap with the right. Okay, I swap with the right. It means my current position of the right is having valid value. My current position of the right is having valid value, so that I can decrement the right. So there is no change in my current and my left. Why? Because when you swap right value with the current, you don't know what is the value you swapped. Right now you swapped 0. It can have 2 also. You don't know that. That's why you keep current as is. So my current is again pointing to same position, and as I replace the 2, I just move the right pointer towards left. Perfect. So now you have Now again you see that my current is pointing to which value now, please? My current is pointing to which value now? 0, right? So when you are pointing to 0, obviously what you should do, where 0 should be swapped? 0 should be swapped with the left, right? So I swap with the left. So when I swap with the left, obviously both are pointing in same position, so that I have, there is no change, 1, 1 and 2. So this is my current and this is my left and this is my right. This is what the earlier input. So I just swapped with the left. So when you swap with the left, one thing for sure, so the left will be moved one index before. The point is, can I move the right or not? So that is, do I need to move the current or not? That is the point. So can I move the right current or not now? Why? Yeah, that's okay. But you didn't do it for right, right? So when I swap with the right, I didn't move the current pointer. So sure that, yeah. So why? So I know this is very tricky point where you need to catch it. So when I swap with the right, we didn't move the current pointer, but when I swap with the left, I must move the current pointer. The point is, here the point is, so I just move the current pointer. Let me tell you why. The point is, when I move with the, if the current is holding right value, if the current is holding 2 right, I already I swap with the right. Then from the right, I don't know which value I get it. But from the left, I'm always sure that I'll always get 0 only. From the left, it means when I swap current with the left, I'm sure that I always swap with the 0 only. So that left, yeah. So this is our current, right? So when I swap with the left, I'm sure that I'm swapping with the left. Uh, Left will not have 2. Left will always have 1. Yes or no? Left will not have 2. Left will always have 1. Okay, you will get to know that. Why? Because left is pointing to 2 means left and right, left and current both are pointing from the same position. So it means when current is holding 2, you already swap with the right. It means even right is somewhat, even current is somewhat right. Left will always point either 0 or 1. It will not point to, because when it is pointing to 2, you swap current with the right. So that obviously my left will always point either 0 or 1. So that there is no problem with swapping. There is no problem moving current. It needs a little bit of your effort. So try spend on it so that you get more clarity. So in simple, what I did, so when I swap with the left, I just increment the current and increment the left. Now again you see that my current is pointing to 0, so that again I swap with the left, so that obviously I can increment left and current. So left and current is coming here, so right is here. Now let's move on. So when I see, now my current is pointing what? So my current is pointing to 2. So you know that 2 must be swapped with the right. So that what you do, you just swap with this right. So when you swap with the right, so you can say 0, 0, and you just swap it. So 1, 1 and 2 and 2. So when you swap with the right, you just need to decrement the right. So that earlier right pointer is here. So that I just move right here. Now again you see that my current is pointing to 1. So when my current is pointing to 1, it is valid, right? So when current is pointing to 1, so you don't need to do any change. So when current is pointing to 1, so you can simply increment the current pointer, so that obviously current comes here. Again current is pointing to 1, you can increment the current pointer, current comes here. Whenever our current is less than or equal to right, then only you move it. Otherwise, here if you move current here, so current pointer is greater than right, so obviously we come out of the loop. I know that things were not very clear. So let me take one more example. So now you understood that. Now you understood that left will always targeting value zeros and right is always targeting value twos. Current is always targeting value ones. So let me take one more input so that you will get things will get clear. You have 2 0 and 1, again 0 and again 0 and again 1. So this is our input. So one thing is sure, please I go little quick, so please concentrate. So current left and right. So now let's see here. Now you will understand what I spoke earlier. So this is my current and this is my right. My current is pointing to value 2 so that it has to be swapped with the right. Okay, so I need to swap with the right. So when I swap with the right, 1 will come here. So there is no change in other values. 2 will go here. And you don't know which value you swap so that you can decrement the right pointer, but there is no change in the current and left. Now you know. Now let's move on. This is what I spoke earlier. So let's move on. So now this is my current. So current is pointing to value 1. So you know that. So this is 0 and 1 and 2. So 0 is represented by left, 2 is represented by right, 1 is represented by current. So now current is pointing to valid value. So current is pointing to 1. So that what I will do, I will just move the current furthermore. So 0, 1, 0, 0, 2, right. So right is here. Yeah, so right is here, so left is here. When current is pointing to valid values, I just increment the current. So that's it. So there is no change. Now you will understand. So now current is pointing to 0, right? So when current is pointing to 0, it has to be swapped with the left. So I just need to swap with the left. So these two things to be swapped. So that 0, 1, 1, 0, 0, 2. Now you, as you swap with the left, blindly you will increment the left. So there is no change. And you already know that left will always hold. When you compare 0 with the left will always hold either 0 or 1. So that as it is holding 1, it means the current swapped value is 1, so that you can blindly increment the current also. So current is here. Now again you see that my current is here, right? Current is pointing to 1, so that when current is pointing to 1 means it is pointing to valid value. So as it is pointing to valid value, just move further. So that 0, 1, 1, 0, 0, 2, right? So earlier current is here, so current will move here, left is here, so there is no change in right. Now again you see that current, now you see, so current is pointing to 0 and left is pointing to 1, so it needs a swap. So what you understand, when you swap current with left, you always swap with the 1, either or 0, so that you can blindly increment both. But when you swap with the right, so you only know that it holds a right value, but you don't know what is the current value you swap, so that don't increment current. That's what I'm trying to say. So here you have left now. So we just swap it. So once you swap it, 0, 0, 1, 1, 0, 2. So left is here. So at index 1. So you just increment further. Current is here. As you swap with 1, so you can increment current, and right is also here. So now you understand current is less than or equal to right. Still it is valid. So that it is time to, current is pointing to 0. So that it's time to swap with the left. So once you swap with the left, the final output will be 0, 0, 0, 1, 1, 2. And current, as you swap it, so left will come here. Current will go little further, right is here. The current is greater than right, so that obviously, can you see it? You can understand, right, what I said? Right, so this is the last swap, right? So you have here, so 0 and 1, so you just swap with this. So current will move further, so current is greater than right, so that you can stop the iteration. Everyone understood the algorithm, please? This is very tricky problem. It's not somewhat you get it in a single shot, but it's a very important problem too. Do you understand the problem algorithm, everyone? No, if I walk through blindly, right, you will get it. Uh, that is not what that is not needed, right? So if I walk through blindly, okay, increment current, increment left, increment right, that you simply get it. That is not an ideal way of learning data structures. You should know why you are doing that. So that's why I was confused. I made you confused a little bit here, but I think with this example you understood. So simple. When you swap with the right, decrement the right pointer. When you swap with the left, increment left and current. But when current is pointing to 1, which means it is valid, so you just increment the current. So what is the time complexity here? Time complexity, please. It's linear, right? So we are just going with 3 pointers, and which is left, right, and middle. So what is the space complexity? If you are not, yeah, so obviously which is constant because we are not taking any additional space, right? We are manipulating with 3 variables, left, current, and right. Everybody is clear. So if you are able to confidently speak about time and space, then you are good that you understood the algorithm. Otherwise, it would be tough. Or do I need to repeat this algorithm, or everyone is clear? Srikanth, Ajay. Hmm. Yeah. So yeah. So so right should point to value 2, and left should point to value 1, and current should point to value 0. So what is the algorithm we are doing? So we are moving. Uh, what we are doing? Can you tell me the algorithm? Yeah, left should point to 0, current should point to 1. So this is what the ideal thing, right? So when let me write it. So if I type it, it will be quick. Yeah, yeah. So now what is the algorithm now? So start current pointer with 0, and if I write the code, it will be pretty simple. Left is also 0, and right is n minus 1. Okay. So if nums of current pointer is 2, then swap with right, decrement in right pointer. So that's it. So we just need to decrement the right pointer. So this is one way, and if nums of current pointer is 1, then just increment current pointer because current is pointing to valid 1, right? So current pointer. And similarly, if nums of current pointer is 0, then swap with left pointer and increment both current and left pointer. So this is pretty simple algorithm, but getting into this thought, right, it is really tricky thing. Let's write this code. Hope you get the clarity right now. So this is what we are trying to do, and here the time complexity is linear and space constant. Yeah. So let me write the code. This is more frequent question in Microsoft. So they they frequently ask this question. So one thing for sure, so I should move my current, which is less than or equal to right. Then yeah, so I can compare my current with the right. Okay, so I compare when my current is 0, or let's go as per the algorithm. So when current is pointing to 2, so I need to swap with the right. So I'll just take nums and left and right. And when I swap with the right, I don't know what value I get, so I just decrement the right. Similarly, else if current is pointing to 1, then I need to swap with the left. So I need to swap with the left. That's it. Else, in that case, what I should do is I just need to increment left pointer and current pointer. Otherwise, you can simply increment current pointer. That's it. So this is what it is. And it's a in-place algorithm. He's not expecting any additional. Yeah, I didn't write swap method. Any mistake, left current, current, right. Okay, so let's see where is the mistake. This is 0, right? So it should be 0, right? So when it is 0, it should be swapped with the left. Yeah. That's it. So yeah, this is, if you see, right, let me stop.